I'm gonna just give my version of a very like interacting minds intro. So this could be us this afternoon. If you think about all the places you've been this week when you've been around other people, you might have been grabbing coffee, designing a new study at the whiteboard, right? Waiting at the doctor's office, just scrolling through Twitter or X on your phone. And at one level, these are all really different activities. You're in different contexts. Maybe you are with people in different roles, but they all have something in common, which is that we're talking. So I have gotten very convinced that language is at the center of our social lives. It's what we're using to express our feelings, build relationships, share ideas, learn new things, and generally participate in sort of a public life, sharing the contents of our minds with one another. So all of these little linguistic interactions add up to something greater than the sum of the parts. And I think that that's what has really interested me, is this sort of sense of shared community that we get out of interaction. The way we coordinate our beliefs and our goals to achieve things like, like building complex, these amazing architecture here in Aarhus. So in addition to being this engine of human culture, it's no surprise that our language also becomes a reflection of our culture. So the way we talk says a lot about who we are, says a lot about our social identities. So we talk differently to different people. And yes, Judy, yes. Yes. That a palpable sense of relief propagates through the room, right? As you're not mentally simulating yourself, like clicking the X button. Okay, so I think that this is this quality of language as a bearer of social identity instantiates itself in talking differently with different people. So if we're writing a paper, we might describe what we're doing using different words, using a different register, than if we were just casually catching up with a friend from our high school or something, right? So we're presenting ourselves in different ways to different audiences, also as a function of the kind of knowledge of our interlocutors. And I think that maybe in its grandest form, as a higher stakes example, language is how we convey our political identities. So, words, particular ways of capturing social movements can spread through large-scale networks to build coalitions that may not have previously identified with one another. So they can kind of create these new formations, new social formations through shared language and sort of create the conditions to engage in collective action. So this is like a lot of weight to put on all of these things coming out of our mouths, right? So I think that a core problem in cognitive science is how language, whether it's in sort of a verbal modality or a textual modality, can accomplish all of these really diverse social functions. So, what gives language its social force? So we've come a long way. I'm in a linguistics department now, so this is like a obligatory syntax tree. So we have a really good knowledge of the kind of structure of language. We have these dictionaries where we've documented, what words mean in many, many different languages. But it's not really clear how these trees and these dictionaries alone provide the kind of mechanistic explanation for the way we use language in practice to accomplish all of these things. So I think that this is maybe preaching to the choir, as they say, but I kind of want to contrast these different views that motivates the projects that I'm going to present. So classical models in psycholinguistics, I think, are primarily concerned with language in a particular person's head. So the answer to how we do all of this stuff is located inside the mind. So if we understand, how I think about language, what words mean to me, my sort of development of learning words, the way maybe even I engage in social reasoning about other individuals, this is kind of the bread and butter of psycholinguistics. So you can see maybe where I'm going with this, which is another view that I think is hopefully shared here is this interactional view. So the interactional view understands these social functions, planning things together, engaging in collective action, as emerging from these cultural processes taking place between minds, right? At the interfaces between minds. So this idea that we're kind of not just having a dictionary in our heads and looking stuff up, but that we're kind of co-constructing meaning with other people through the language modality. And the bet that I make in my research program is that we can't really understand the social force of language until we place it in this functional context of real social interaction, of doing things together. So the goal is to, I am trained in cognitive science, kind of computational cognitive science, so I'd really like to build a rigorous computational account of language embedded in social interaction. Social interaction is shaping language over time, so I want the best of both worlds. I want to link the processes happening inside individuals with the processes taking place between individuals and try to ground these more macro scale cultural processes in models of cognition. So the first part of the talk will zoom into dyadic interaction. So this site of short-term co-construction of meaning. So essentially the kind of 15-minute chat we might have in a coffee shop or a doctor's office, and try to understand the computational principles that allow us to adapt to one another over those short time scales. And then I want to pop up a broader level to understand how these small interactions may begin to add up to emergent conventions at the level of a larger community. And then finally, I want to kind of grapple with this question that has been engaging me a lot recently about code switching across communities. So the idea that we're representing who we're talking to and which conventions hold for which people. And this is not just true for multilinguistic code switching, but I would argue within a single language across different social partners. Okay, so that's like a very kind of theoretical way of jumping in, but I want to ground this in the lab. So I'm going to start by introducing you to, well, you probably already know this paradigm, but sort of my take on this paradigm called a repeated reference game. So this is a way that you can understand a specific function of language, which is reference, referring to things in the world. Okay, so this is like a very small bite out of all of the things we do with language, with one another, but it's sort of a fruit fly of dyadic repeated language use. So in this game, and yeah, I should say this goes back to like the 60s, so it has a very rich history, and probably many of you in the room have kind of your own takes on this paradigm. But here's the way we did it. So we took these little shapes, these tangrams, that were kind of popularized, I'd say, by Herb Clark in the 80s, and set up a pair of people and assign them to the roles of speaker and to listener. So the speaker is trying to get the listener to click on one of these shapes, right? And if you're in the listener role, you might hear the speaker describe one of these in this way. So this one looks kind of like a centaur rearing up with its hoof in the air on the right and its body close to the ground. So if you're the listener, you're kind of listening to this and scanning this set of objects and trying to think which one are they talking about. And does anyone have a bet?
Top left.
Top left. Anyone have a different? Consensus. This is a good description. Okay, so this is sort of something that you might do on the first round. It's a very detailed description, and indeed, if you clicked on that, you'd get positive feedback, right? So you'd say, good job. Okay, so then you move to the next round of the game, and if you're on the speaker side, you see a different one circled as the one that you need to produce a referring expression for. So does anyone want to take a crack at this one? It's kind of a classic. It's the ice skater, right? We already have conventions for this one. I love it. So you say the ice skater, but maybe your partner isn't as versed in the literature, right? They haven't done the demo dozens of times. So they're like, you know what, this one looks kind of like an ice skater, you know? It's got its arms out to the sides, maybe. And then you'd get negative feedback. So you as the speaker would see, okay, your partner clicked that one, and maybe next time you should mention something about like a leg being up in the back or something like that. Okay, so that's a regular reference game. What makes this a repeated reference game is that you loop through each of these multiple times. So after you make your way through all of the targets, you switch and the speaker becomes the listener, and you do it again, and then you do it again, and you do it again. What I was interested in here is, you know, what you can do when you have a larger corpus than classical work allowed you to do. So the classic work would do this with maybe 12 to 15 pairs of people, and then would annotate the transcripts for various things. I was very interested in drawing on sort of tools from NLP, computational linguistics, to understand patterns in the way people refer to these things that we couldn't have looked at in the 80s. So this is kind of taking replication and seeing if there's more juice we can get out of this paradigm. So just to give you a flavor, and maybe one of my favorite examples is a pair that started out calling this guy a guy who looks like one of those wavy tube guys leaning toward the left, and I'm assuming this is a cultural universal. You have the wavy tube guys like everywhere. Maybe not like a car dealership, but it's kind of this like balloon
guy.
You see them on TV.
You see them on TV. Okay, yeah. So we've mass media has introduced the wavy tube guy. Good. So their partner gets it. So this was a good description for their cultural context. And what do they say the next time? So you might expect that this worked, so maybe they just do it again. But this time they just call it the wavy tube guy, and then by the end they're just calling him the wavy man, right? So if you're interested in sort of conventions and pacts and the kinds of things we can get away with when we build up common ground with people, this is a very interesting utterance as a referring expression, because if you brought in a new person that wasn't there for that whole thing, this isn't what wavy typically means or whatever, right? So there's sort of, if you ask a formal semantics person to like write down a lambda expression for the adjective wavy, right, as like a modifier, they maybe wouldn't write down something that applies to that guy. So broadly, utterances get more efficient. People start out using about 16 words, and then by the end they're getting away with these very short things while remaining highly accurate. So this is a visualization that we attempted to understand the traces that different pairs take through semantic space over the course of this game. So this arrow starts at a embedding of the utterance that this particular dyad used at the beginning, right? So they started out calling it a person raising their arms up like a choir singer, and then by the final round they were just calling it the choir singer. So we're going to put everybody in the same shared space, and you can kind of get this map of people that ended up with different conventions. So over here there's a bunch of games, and every arrow is a different game. Okay, so these are kind of independent pairs. So all of these folks ended up calling it flying. In the upper right, people ended up calling it a ghost. Down in the bottom right, people ended up calling it an angel. So those are like at least three major clusters, three kind of equilibria. But you can also see that there's kind of everything in between. So, in addition to the choir singer, we've got like the inflatable balloon guy, crazy arms, so forth. So this is, I think, a way of looking at the way that there's two things that we kind of noticed here. The first is that everybody starts out kind of overlapping a little more. You might worry this is like an artifact of the way we embedded it, but we looked at it in other ways, and people do start out with just more in common. Like every game starts out talking about like the arms being up, for example, but then some of them drop that and just end up calling it flying, or just calling it a ghost or whatever. So there's this divergence where different games end up in sort of different places. So there's many different solutions, and this is classically in the literature on social convention, the quality of arbitrariness. And that's a bit of a tricky concept, because it doesn't mean that any word would be equally likely, but it does mean that conditioned on using it, there's anything could serve this purpose, right? So basically the counterfactual alternatives are there's many ways to succeed at this game. And then the second quality is stability. So once people got over here, they didn't really move that much, okay? So people didn't call it flying on one round, and then ghost on the next round, and then angel on the round after that. They kind of, once you coordinate on something, there's kind of no incentive to deviate from it. So that's kind of the other classical property of social conventions, a arbitrary but stable solution to a recurring coordination problem. So, yes, Arno.
Here you're looking at first and last occurrence.
Yeah.
Have you looked at the actual path through the files?
Yeah, it makes this plot really messy.
Yeah.
But you can look at, for example, like how so people kind of get there at different speeds. So you can look at that. So you can look at the rate of change.
Exactly.
Yeah. And it slows down, right? So that's kind of the more graded version of the stability arguments, is that they change a lot from the first round to the second round, change a little less from the second to third, and by the fourth or fifth rounds, they're not changing that much. But yeah, there's a lot of things that we did with these data in the paper, and the corpus is open and available if you want to look into other signatures. So just as a quick shout out, in the intervening time, we sort of got bothered by the fact that there were really only a small number of these shapes that had been used in every single study. So the Clark work had 12, and other work added maybe 10 more. But in this, we got out of the back of a tangram puzzle book like 1,000 of them, and we annotated them for both whole shape descriptions. So this is like getting a prior over descriptions for a given object. So this is sort of the kind of thing people would say on the first round of a game. So you can look at things like nameability, does everyone sort of out of the box call it the same thing, or is there a lot of variation even at the very beginning on how they describe it? But we also got these part annotations, which we thought was very interesting, both cognitively, because you can call it very different things, but you can still maybe give it a similar segmentation map. So you could still, say that like this is a head and this is a leg or something, but call it like a sheep instead of a dog or something like that. So this is a large resource that's open now. So if you want to run studies that have these kind of convention formation qualities with larger stimulus sets, is a good resource. Okay, so sort of with that as a behavioral paradigm that I felt confident was eliciting conventions in the lab, now I was interested in a computational model. So how do you explain this kind of gradual increase in efficiency and the stability and arbitrariness across different groups? So taking a step back, there's been a lot of models proposed over the years. Agent-based models, neural network models, Bayesian models, and they all have a couple of things in common. Okay, so there's this, at a first pass, encoding and decoding problem. So you have a speaker that wants to get stuff from their head into the listener's head, and if they all have the same conventions, the problem is solved, right? So conditioned on sharing conventions, you can encode any intention into a signal that the other person can invert back into that intention. So a lot of communication can be explained by sort of existing prior conventions that we've acquired over the course of our lives. So this is kind of the initial state that people are bringing into this task. More recently, there's been a lot of work on theory of mind and social reasoning in these models. So you do something like this, where me as the speaker is thinking about how the listener is going to reason about other things that I could have said. Maybe they have mistaken beliefs about my knowledge. Maybe they don't know who I am, or they do know who I am, and I want to take all of that into account when I interpret what they're trying to say to me. So we equip the conventions with this additional layer of social reasoning on top, and I am going to call that the kind of current Neo-Gricean synthesis in modeling land, where you have this basis of semantic understanding, and then kind of enrich it with this recursive theory of mind-based social reasoning. But you can maybe see where I'm going with this is that all so far is kind of more individual view, right? So how do we get this interactive coordination into the model? And the basic way we approached this, taking inspiration from like Donald Davidson and lots of other models of this distinction between prior theories and passing theories, is you start out with a best guess. So you don't know exactly what is in your partner's head, exactly how they're going to interpret what you mean. Instead, you have a particular parameter that is kind of your current best guess about what your partner is going to interpret based on all of your experience over the course of your life. And then you get feedback. So this feedback step is the critical ingredient that allows you to update your beliefs in real time with your particular partner. So this might be a back channel, like you say something and they look at you quizzically, right? Or they say, huh? Or they do some action that wasn't what you intended them to do, right? So these are all observations you can make of a social partner that gives you a statistical cue you can use to back out a better model of what they might think that you're intending. So if that's the Neo-Gricean synthesis, this was a model that we finally wrote up last year in this psych review paper, where you start out with some uncertainty about whether a meaning is shared. So this might be like think about an acronym you use in your field or something, right? If you go to a conference, you might be unsure whether a particular person is familiar with that acronym or not, right? So that's like uncertainty that you're bringing into that interaction. But then so that you can think of as like your prior over meaning. But then there's this mechanism for partner-specific belief updating. So as you get feedback, you update your beliefs about whether a meaning is shared or not. And that conditional distribution of your beliefs after receiving feedback is just going to be modeled as a example of Bayesian inference. So there's a forward model you can have, and this is kind of drawing on that social reasoning literature, where you can say, hypothetically, if my partner had this in their head, that would generate certain behavioral signatures, right? So if they thought I meant this other thing, they would do this. If they thought I meant this thing, they would do that. And you can use those forward models of your social partner to invert your beliefs about what's in their head as far as shared meaning goes. Okay, so those are two ingredients. It turns out if you put them together, with these models of social reasoning as a speaker, you have some informativity where and this is kind of like narrowing down to the reference game context. You're trying to be informative, you're trying to make them believe that you're talking about a particular target object given your utterance and your current beliefs about what is in their head. And you don't like to say more words than you have to. So those are like two terms of a speaker deciding what to say. And this is, so far, there's no interactive work here. But then if you add in this uncertainty, you get an update that I will skip ahead and give you the punchline that if you run this model over multiple repetitions where both agents are doing this kind of belief updating about what's in their partner's head, you get a increase in efficiency while remaining highly accurate. So this is recovering the qualitative effects we observed in that reference game. So I want to go a little fast. You may have questions about the model because I want to get ahead to the community level. So maybe we can come back to those details after I give you a final piece of the puzzle. So there, as an answer to how we are jointly constructing this shared meaning in a dyadic setting, I kind of pinned it on these two mechanisms. One is you need some kind of uncertainty, otherwise you would just say the same thing with every person, meaning like there's no reason to say like a long thing at the beginning of the game if you already think that everyone would understand the short thing, right? So the idea is the long thing hedges against the possibility of misunderstanding. So you add more and more modifiers and things to increase the probability that your partner understands you. Okay, and maybe before I go on, you may be unsure that this is like really operative more broadly. So with student Sunyu Murthy, we ran a study testing whether people really have this kind of uncertainty, because this is kind of a weird way of thinking about language if you're like a traditional formal semanticist, where we kind of have a point-wise representation. It's just, this is, what a word means. So you can actually elicit for people a expected agreement, like, here's what I think this means, and here's how strongly I think other people will agree with me. And then you can, if you run that with a lot of people, also calculate the actual agreement, right? So how often did people, like other people, actually say the same thing as you? And this is pretty well calibrated. So people have uncertainty where they think that certain things are kind of idiosyncratic, where they're like, okay, I think of it this way, but I'm not sure, I don't think other people are gonna agree with me. And they're usually pretty accurate about that. So it does seem like there's some probabilistic representation of whether a meaning is shared a priori. And then for this second mechanism, you may wonder whether this kind of reference game is really sort of the best way of testing this. So you can extrapolate the paradigm out to more complex procedural assembly tasks. So for example, like tower building, this is work with Judy and one of Judy's students, Will, where we looked at conventions not just for like referring to particular things, but coordinating on sort of larger and larger chunks of towers. So this kind of partner-specific belief updating sort of works at multiple levels of abstraction, where you're not just talking about a particular tangram, but you're coordinating on sort of larger conceptual chunks. Okay, so after that shout out, I want to get to this problem of generalization. So how does meaning actually emerge at a community level? And to kind of preview that, you can kind of think of this problem as taking a pair that converged on flying, taking a pair that converged on ghost, and then swapping them. So if you take a person that said ghost and another person that said flying, and you put those two people in the room together, what do they say now, right? So now there's an issue where you have to transfer in some way the thing you coordinated on with one partner to another partner. And to put this in a different way, conventions, and what makes conventions useful is that we can talk to complete strangers, right? Conventions are properties of large communities, but our experiences are with individuals. So there's an inductive problem here where we have to extrapolate somehow from individual interactions to form expectations about people that we've never met before and whether they're going to understand a particular convention. So how do we extend this model to generalize to new social partners? And one of the convenient things about Bayesian framework is that you can have a hierarchical structure where you assume that different partners are drawn from a distribution that shares something in common. So this something in common I'm going to denote by this big theta. So the big theta is like a hyperparameter that says, given some beliefs about a big theta, I have a expectation over what that particular person will do. And given feedback from that person, I want to eventually form beliefs about a new person. And the way that this works in a hierarchical Bayesian model is that you kind of trace this path through the graph, where you use feedback to update your beliefs about your specific partner, but because you think that partner was drawn from this broader distribution, you can also start to change your beliefs about that broader distribution. And if you have beliefs about a broad distribution, that makes predictions about a new person from that same distribution. So there's kind of this inferential pathway through hierarchy, as long as you think that people in a community have something in common. Okay, so here are some other ways that it could work. So what I just described is a partial pooling model. So hierarchical models, partial pooling models, kind of different words for the same thing. This is also if you use like Elmer or mixed effects models, similar idea, right? So that should be, just to put things together, this is kind of like the cognitive model version of using like random effects or something, right? But instead of using this full hierarchy, you can imagine simpler models that don't use the full hierarchy. So one possibility is a complete pooling model. So a complete pooling model assumes that everyone comes from the same distribution, but doesn't represent partner-specific meanings. So this is essentially what most agent-based models do in the, if you're familiar with, for example, the language evolution literature, like Luke Steele's models, most agent-based models from sort of, the kind of Steele's group, or like you have a monolithic representation, and you assume that it is just the same thing is used across every partner, right? So you're not representing variability across partners where you say one thing with one partner and a different thing with another partner. The alternative, which is more of a straw man, but I think useful to think about as a conceptual possibility, is that you're not pooling at all, right? So you form very high resolution expectations about a particular partner, but when you go to a new partner, you're not really transferring. You're just like partitioning off your expectations about different partners from one another. So we wanted to compare these in a behavioral experiment. So in this experiment, we took the same repeated reference task that we used in the first parts, but we put it on a little network. Okay, so we recruited a group of 4 participants into a shared environment, and we paired them up in the following way. So it was kind of a round robin. So red interacts with purple, blue interacts with green. They play a repeated reference game. They start calling it the ghost or whatever, and then they swap. Okay, so now purple is playing with blue, and or red is playing with blue, and purple is playing with green. And then third time, they're paired up in a different way. And the thing that we're interested in is what happens at these partner swaps. So that's what's going to distinguish between the models, is how you take what you did with one partner into an interaction with another partner. So here are the predictions. The complete pooling model predicts that you're going to keep forming conventions, but these vertical lines represent when you switch partners, and a complete pooling model doesn't do anything differently at those boundaries, right? You just carry over what you did with the first partner into the second interaction because it's all evidence for the same set of conventions. The no pooling model is able to form conventions with a given partner, but you get these big jumps, right? So you basically revert back to your prior when you start talking with a new person because you're not carrying anything over across the boundary. And then the final sort of prediction from the partial pooling has this combination of those effects. So you get these jumps from partner specificity, but you get some savings as you go. So yeah.
Sorry, how is it that in the complete pooling condition you don't see those jumps? Because isn't there is error in feedback, right? So what is the agent doing at that point?
Right. So this is the speaker side, and this is assuming that they get it right. So this is I say something that's long enough that my partner understands me, right? And then this is assuming, what's interesting here is this one isn't dependent on feedback, right? This is just what I say right off the bat with my new partner. If my partner got it wrong, then I might pop up for the second one, but the signature that we're interested in is this there's no jump up from the last thing with one partner to the first thing with a new partner. Does that make sense? Okay. Great. So the empirical data showed this. So we get this signature statistically of the partner specificity. So that makes the complete pooling model. Complete pooling model has a really hard time explaining that. Why you would just, even though it was 3 seconds ago that you were calling it the ghost, why you would suddenly revert back to your prior with a new partner. But you also get this progressive willingness to start off the bat with a completely new person and say something shorter and more conventional. So you might worry, though, that this is kind of just an effect of getting lazy, right? So people are getting tired as the game goes on, and they're just kind of leaving out words or something. So this isn't really a real effect of generalization. So what would really be compelling from my point of view is a network level convergence on the same convention. So the question is whether even though you're having these pairwise interactions, you start using longer, or you start being more willing to say the same thing that someone you're not even interacting with is saying. So the first kind of prediction that is easier to think about on this alignment score, so I'm going to show two lines. The solid line is the alignment with the person you're currently talking to. Okay, so this is like, I say something, you say something, I say something, you say something. Are we saying the same thing, like in a dyadic interaction? And for a no-pooling model, yes, we're good at coordinating locally with a partner that we're in the room with. The dashed line is across dyads in a network. So it's across the two separate rooms is what I'm saying in this room, the same as what you're saying in that room, right? So this is like, even though we're not face-to-face, are we still using the same convention? And under a no-pooling model, there's no point at which that becomes more likely. Every room sort of starts from scratch and ends up at a sort of arbitrary equilibrium. The complete pooling model, the dashed line goes up, so that's the network reaching convergence, right? So that's, even though I'm not currently interacting with you, we call it the same thing. That's like the convention is spread. But it comes at a cost, which is that I'm carrying things into the second interaction more confidently than I really should, and I'm actually not even aligning with the person in the room with me, right? So I'm calling it one thing, you're calling it another thing in the same room. And then the partial pooling kind of preserves your ability to adapt to your partner in the room, but you gradually converge across the network. And that is the signature that we saw in the empirical data quite strongly. So this was very compelling to me that the network as a whole is converging to a shared convention across these dyadic interactions. Okay, so I want to make sure I'm watching the time. I'm going to give a quick shout out to a project of interest, and then I'm going to wrap up. So the project of interest, yeah, okay. So unfortunately, despite the shout outs, I'm going to not talk about the hyperscanning, but we can talk about that offline. So this is a idea, this generalization to new partners was very intriguing to me, and I, like everyone else in the Interacting Minds, kind of community, really like the idea that we're not just sort of forming these point-wise interactions, but we're actually doing something like, aligning our conceptual spaces or something, right? Like I have some way of representing all of these things, and by aligning on a particular way of talking about a particular tangram, it's affecting the broader space in some way, right? So this project with Anya G and Yoav Artzi, who were the same folks I worked with on the kilogram data set, we did a design where you play a repeated reference game with a particular target, but then in the pre-phase, before the reference game, we elicit descriptions of a bunch of other tangrams. And in the post-phase, we elicit descriptions of those other tangrams. And the question is whether aligning on one tangram moves your description of these other tangrams closer to your partner. So is this kind of like a magnet or sort of like it warps the semantic space in some way by aligning on a particular tangram, that it actually pulls these unseen tangrams closer together. So this is looking at generalization to other nearby tangrams. And we actually found, very interestingly, and this is kind of fresh off the presses, that the willingness to extend a convention to nearby things, so sort of the power of attraction of this aligning on these other unseen tangrams falls off as a exponential function of the similarity of those tangrams to the one that you coordinated on. So this is, if you're familiar with like a Roger Shepard law of generalization pattern, this is, I think, a instantiation of that in a joint conceptual space. So I'm really excited about this result as a way of thinking about how conceptual alignment kind of like propagates outside the realm of like a specific alignment experience. Okay, so to wrap up, I'm very interested in this pathway between the cognitive things going inside a particular individual's mind, the way that they represent uncertainty about shared meaning, the way they are updating their beliefs about different partners, and the consequences that has for larger, more macro communities. So how can we ground large-scale cultural phenomena in specific cognitive mechanisms? And I hope that this sort of model framework begins to put some of those pieces together. So thanks for your attention. So